This is now your sample number 5. We have a tripod, supports a load P of unknown magnitude. Find the maximum magnitude of P that can be supported if the force in any leg is limited to 8 kilonewton. Assume that the legs are two forced bodies. Okay, so the force in any leg is limited to 8 kilonewton or not to exceed 8 kilonewtons. Okay, so first, let us try to determine the coordinates of the different points. So your A, so this is your point A, so x coordinate is 0, and then your y coordinate is 2.4 meters, so that is 2.4 meters, and the z coordinate, that is the z, so your y is, okay, y is 0, and your z is equal to positive 2.4 meters. For point B, so point B, so your x in here is equal to, in the direction, that is equal to 0. So this is the direction of y, and that is equal to positive 1.8. So that is 1.8. And your z, so that is the direction of z, that is equal to 0. For C, this is your point C. So the x coordinate is, there's one in here, which is back of the origin. So we have negative 1.8. And then your y coordinate of point C is equal to, this is the x-axis, so that is the y coordinate. Hence, it is negative 0.9 minus 0.9, and your z is equal to 0. Your point D, the x coordinate is 1.8. So we have positive 1.8. So it is forward of the origin. And then your y coordinate of point C, which is equal to negative 0.9 meters. And the z coordinate is now equal to 0. Okay, let's try to draw the free body diagram of joint A. So we have the first P, then we now have your FDA, we now have your FAC, and we now have your FBA. Now, let's try to write the forces in Cartesian vector form. So let's start for AB. For FA, let's start now for FAB. So for FAB, in Cartesian form, your FAB is now equal to the magnitude of this force, that is FAB, multiply this one by a unit vector in the direction AB. Again, the unit vector in the direction OB is now equal to introduce a position vector AB all over the magnitude of AB. So let us try to determine now the components of the distance component of the distance AB. So we have now the components of the distance AB. Now, you try to take note that this is directed. So this is FBA. So this is FBA. So FBA, so this is now your FBA. So that is FBA, and is now position vector BA. So that a unit vector BA. So we have a unit vector BA. The magnitude of the position vector BA. So we have to compute now the components of the distance BA. So we have your x component, we have your y component, and we now have your z component. Now, your leg BA is directed from point B to point A. Therefore, it is A minus B. So it's directed from point B to point A. So the tip is at point A, and the tail is at point B. So tip minus, tip or head minus the tail. So that is A minus B. So that is your x component is now equal to 0. Your y component is 0 minus 1.8, and that is equal to negative 1.8. And your z component is equal to 2.4, that is 2.4 minus 0, or that is equal to 2.4. Hence, the position vector BA is now equal to, so your x is 0, xi, so we have your yj minus 1.8j plus zk, and that is equal to 2.4k. Now, the magnitude of this position vector is now equal to the square root of 1.8 square plus 2.4 square. And this is therefore equal to 3. So let us try to express now BA in Cartesian vector form. So your is now equal to the magnitude of this first, or of this vector, multiply this one by a unit vector BA. So that is minus 1.8j plus 2.4k all over 3. So that your FBA in Cartesian vector form is negative 1.8 all over 3 is 0.6. 0.6 FBA J plus 2.4 all over 3 is 0.8. That is FBA K. In scalar form, your FBAX is equal to 0. Then your FBAY is equal to 0.6 FBA. And your FBAZ is equal to 0.8. We have FBA. So that is the components of the force BA along the X, along the Y, and along the Z axis. For leg CA. So that is now 4 FCA. So for FCA, your FCA, again in Cartesian vector form, is equal to the magnitude of that force or of that vector, multiply this one by a unit vector CA. Again, the unit vector CA is now your position vector CA all over the magnitude of this position vector. Now, again, let us try to determine the components of the distance CA. So, again, you have your X, your Y, and your Z component. So, this directed from C to A. So, we have A minus C. So, that is 0 minus and minus 1.8. So, that is equal to positive 1.8. Have 0 minus and minus 0.9. So that is positive 0.9. And the Z component is 2.4 minus 0. 0.4, or that is equal to 2.4. And therefore, the position vector CA is now equal to xi, that is 1.8i. Okay, plus yj 0.9j plus zk 2.4k. And the magnitude of this position vector, again, is now the square root of 1.8 square plus 0.9 square plus 2.4 square. And this is equal to the square root of 9.81. Hence, FCA in Cartesian form is now equal to its magnitude by a unit vector. So we have 1.8i plus 0.9j plus 2.4k all over the square root of 9.81. So FCA is now equal to 1.8 over the square root of 9.81, 0.575. 0.575 FCA. So that is FCA I plus 0.9 over the square root of 9.81 is 0.287. 0.287J. plus 2.4 over the square root of 9.81, 0.7 plus 0.766 FCAK. In scalar form, your FCAX is 0.575 FCA. FCAY is now equal to 0.287 FCA, and your FCAZ is equal to 0.766 FCA. Now, for FDA. So, in Cartesian vector form, this is equal to its magnitude times a unit vector dA. Again, your NDA is now equal to a position vector directed from point D to point A all over its magnitude. So we now have the components of the distance dA. You have your X. We now have your Y and your Z component. Now, again, this is directed from D to A, so again, A minus D. So it's 0 minus 1.8, so that is negative 1.8. 0 minus and minus 0.9, so that is positive 0.9. Then we have 2.4 minus 0. So we have 2.4, so that is equal to 2.4. Hence, the position vector RDA is now equal to xi, so we have minus 1.8i plus yj, so 0.9j plus zk, 2.4k. Its magnitude is now equal to the square root of 1.8 square plus 0.9 square plus 2.4 square. And this is equal to the square root of 9.81. So, your FDA, again in Cartesian vector form, is now its magnitude times a unit vector dA. So we have minus 1.8i plus 0.9j plus 2.4k all over the square root of 9.81. So this is equal to 1.8 over the square root of 9.81, and that is equal to minus 0.575 minus 0.575 FDA I plus 0.9 over the square root of 9.8, that is 0.287 F dA, and that J plus 2.4 over the square root of 9.81 is 0.766 F dA K. Again, in scalar form, your F dAx is equal to negative 0.575 F dA. And your F dAy is equal to 0.287 F dA. And your F dAz is equal to 0.766 F dA. Okay, for T. Now, you try to take note that T is directed downward along the z-axis. And therefore, your Px in here is equal to 0. Your Py is equal to 0. And your Pz is equal to negative P. That is equal to negative P. Now, summation of forces. Let us now apply the three equations of equilibrium for concurrent force system in the three-dimensional force. Summation of forces along the x-axis is equal to 0. So we have F dAx, so this is now your F dAx plus F cax plus F dAx plus Px is equal to 0. So F dAx is equal to 0. Then FCAX is 0.575 FCA. FDAX is negative 0.575 FDA. And your Px is equal to 0. Hence, this is equal to 0. So we now have your FCA is equal to FDA. So this is now the first equation. Next, summation of forces along the y-axis is equal to 0. So we have F BAY plus F CAY plus F DAY plus PY is equal to 0. So your FBAY is negative 0.6 FBA. Then FCAY is 0.287 FCA. And your FDAY is positive 0.287 plus 0.287 287 FDA, your PY is equal to 0. Hence, this one is now equal to 0. So, let's consider this one as the second equation. Now, summation of forces along the z-axis is equal to 0. F BAZ plus F BAY plus F DA plus F BAZ plus F CAY plus F DAY plus PZ is equal to 0. Now, your FBAZ is 0.8 FBA. Your FCA Z, so FCAZ is equal to 0.766. So we have plus 0.766 FCA. Your DAZ is, so we now have your DAZ. So that is plus 0.766766 FDA, and your PZ is minus P is equal to 0. So this is now your equation 3. Now, since the force in any leg is limited to 8 kilonewtons, so if FDA, so if FDA is equal to 8 kilonewtons, then from equation 1, FCA is equal to FDA, and that is therefore equal to 8 kilonewtons. Then, let us try to determine FBA. So let's try to determine your FBA. So let us try to substitute this. Okay, so we have to substitute in equation 2. So from equation 2 minus 0.6 FBA. So that is FBA plus 0.287 FCA is 8 kilonewtons plus 0.287 FDA is also equal to 8 kilonewtons. So that is now equal to 0. Solving for FBA, this is equal to, FBA is 7.5 7.653 kilonewtons. So 7.653 kilonewton is less than 8 kilonewton. Therefore, the legs are not overloaded. For the legs are not overloaded. Let us try to solve now the value of P. Now from equation number 3 or equation 3. So we have 0.8. FBA is 7.653 plus 0.766. FCA is 8 kilonewtons plus 0.766. FDA is 8 kilonewtons. And then minus P is now equal to 0. Hence, the value of P is equal to, this is equal to 18.378 kilonewton.
From the what is the difference in elevation? So difference in elevation will be equal to, so that will be benchmark 1 minus benchmark 2. Okay? So, ano yung sagot natin? 98.5 minus 92.076. That is equal to, ano yung sagot class? What's the answer? So this is equal to 98.5 minus 92.076. So this is equal to 6.424 meters. So the answer is 6.424 meters. That means the viscosity ng inyong sabihin ito. Siya ay down. Okay? So that is for and then we also have our arithmetic check. So what's the arithmetic check for
We now have